Hello everyone, welcome to this channel. So in this video, we will continue our topics in probability. So now we want to talk about the independence of two events. So what means two events are independent? So that means you can see these two events have no effect on each other. So in other words, like if one event happen or not, this won't affect or give you any information the other event will happen or not. For example, if we flip two coins, and then no matter what the size we will get from the first coin, this won't affect when we flip the second coin. So that means these two events are independent. However, if we talk about two events, like we flip one coin and then the E1, like event E1 means we get a side head, and the other event E2 is we get a side as tail. So these two events are not independent because when we flip a coin and we get a head, so this can help us get a result means we cannot get a tail because we can only get one side of this one side after we flip one coin. So that means now get a head or tail from flipping a coin is not independent. So this is some example of what's meaningful two events are independent. And then if we in probability, we can use the probability of events to help us check two events are independent or not. So here to check two events are independent or not, we can have three methods to help us check this. So we can check the condition probability between A and B. So this is the first two equations here. And the third one is we can check the intersection of these two events. So if the probability of the intersection is equal to the product of the probability for each of them. So the idea of this is you can think when we see conditional probability, what we read this, we say this is a probability A given B. So that means for a given information of B, what's the probability of A. So if these two events have no effect on each other, that means given the information of B, we still have this have no usage for us to check what the probability of what event A will happen or not. So that means by given this information of B, this won't change the probability of A. So this is the meaning of the first equation. And for the second one, actually we just interchange this A and B, but the meaning is exactly the same. And the third equation, actually, if we plug in this intersection of probability of intersection of A and B, so in fact here what we can know is we know this can help us imply the previous two equations. Because by the definition of conditional probability, we can use the third equation to get the first two equations. So that's why we have three ways to check two events are independent or not. And of course, for this independence, except besides we check independence of two events, we can also check this for multiple events. So for example, we assume here is event like n events, and then we can use a similar equation to the third equation here to help us check n events are independent or not. So let me write down this. So here, if we have n events, then how we can check they are independent or not? We need to select some events from this total n events. So this is we select two of them, and then 3 and 4 and 5 until n minus 1, and also n. We check the intersection of all of these selections and check the probability of their intersection. It is equal the product of their each probability. So if we can check all of them, then we can say these events E1 until En are independent with each other. Okay, so this one actually is a really annoying and kind of taking a long time to check this, but we still have this result. Okay, so now let me give you an example of this. So let us talk about this problem. So this problem is, assume here we have 500 semiconductors that are produced by one factory, and then we assume inside these 500 products we have 493 satisfy the standard, but 7 of them are not. And here we assume we are interested in 2 events. The first one is the first sample is not standard, and the event 2 is the second standard sample are not standard. So the experiment is we want to select 6 samples with replacement, and the question is E1 and E2 are independent or not. Okay, so how we can compute this? Of course, the method to compute this is we compute the probability of the intersection, or we compute the conditional probability. So here, what I want to do here is I want to compute, for example, the conditional probability here. So what this means? This means here I want to check if the probability of E1, E2 given E1 is equal the probability of E2 or not. Okay, so here let's first compute what is the probability of E2, because this one looks a little more simple compared to the left hand side. So the probability of E2 is when we select the second sample of this total products, what the probability we will find this sample is not a standard. If we want to compute this one, there is one word very important in our question. The question is that we select these samples with replacement. So what's meaning for with replacement? It means after we select the first one, we will record this one is a standard or not, and then we will put this product back to the for the other 499 products, and then we select randomly again. So that means when we select the second one, we don't know which one is standard or not in this total 500. So here with this replacement, that means when we select the second one, we still select one from the total 500, and we only know 7 of them are not standard. So in other words, here the probability of our E2 is just use the number of not standard semiconductors divided by the total number of the semiconductives, and this is a equally likely event, right? Okay, so then this is a value of the right hand side, and then what is the value of our left hand side? The left hand side, by the meaning of conditional probability, it means even though we know what is the result of our E1, then we want to know what's the result for our E2, the probability of our E2. So as I described this experiment, after we record the first sample we select is standard or not, when we put it back to our total product group, when we select the second one, this won't change any result, no matter the first sample is a standard or not. So actually here, in other words, even though we know the result from the first event, the result for our conditional probability here is still same. It's still equally likely events with the 500 products. So that means actually here, by this one, we know these two are equal each other. or in other words, that means we have E1 and E2 are independent. Okay, so this one is like we can use the, if we understand this experiment clearly, actually we even don't need this computing of two probability. Just from this question, we know this is an independent event. However, let's assume what happens if here we change this with replacement to a without replacement. What will happen? So in this case, if we change this to without replacement, what this means? This means if the first E1, we have this, we have our first standard is a not standard one, and without the replacement, what we left? We left a 6 not standard sample with 499 sample. So then when we select the second, this probability will become 6 over 499. However, on the other hand, if the first one is a standard, then what we will left? We will left 7 non-standard over 499. So that means by this explanation of the question, we know when the experiment is randomly select the 6 sample without replacement, then the probability of the second event E2 will depend on the result of the first sample is standard or not. So that means these two events won't be independent. So this is two example of two events are independent or not. Okay, so this is my introduction of the independence of two events. And then in my next video, I will talk about very important terminology. What is random variables in probability? So hopefully I will see you in the next video, and please subscribe this channel.